Welcome to the channel where we make statistics simple and easy for all of us to understand it. For most statistical analysis, you'll understand normality plays a critical role. Otherwise, your results might not be speaking true to what is expected. One of the main ways that people tend to use in evaluating normality is through histograms as a visual way. So, but in SPSS, how do you perform normality test and see if your data is viable to continue with that test? So we have two variables here, that is height and weight. So we want to see if they are normal. So go to analyze. So in descriptive statistics, we have a function known as explore, where we want to explore our data. So of course, we have both of them. We have weight and height. And then now the critical thing here, we are not interested in their descriptive statistics, but we still put it on. So plots. So the plots here we have, let me first of all even try to put histograms, or the way we usually put it. So put histograms, and then I just click OK and see what happens. So we have, of course, the height here and all the descriptive statistics, but I'm mainly interested in these, in the histogram. So you look at the histogram here. You can see that our data, can you tell if this data is normal or not normal? In one way, we are not be able to fully tell because we can see here we have some pickedness because we expect like a curve. We expect a curve to come this way. But the good thing, can see our data doesn't have any outliers. When we go to weight, we can say weight is a little bit normal, but although again you can see here, we can say it's normal because at least we have like a curve on this end. But on this other end, we don't have such a curve, although we have a picked bar in between. But now we cannot make a conclusive about normality. So what do we do? So we go back to analyze, and now this time case you go to plots and then normality plots with tests. So go to the normality plots with tests, and you click OK. And here we have the test of normality. So remember, we have two main major tests of normality: the Kolmogorov-Smirnov and the Shapiro-Wilk test. So these two tests help us in showing if the data is normal or not normal. When do we use Kolmogorov and when do we use Shapiro? We use Kolmogorov when the data, when we have the sample size is at least 50. 50 and above, we tend to use the Kolmogorov. And Shapiro, any small data that is 50 and below, we recommend to use Shapiro. In this case, our data was 48, so the best test is Shapiro. So if you go to Shapiro, you'll find that height, it tells us that height is not normal. Because at the end of the day, you can see the significance level here. The p-value here is 0.447, which if let's say our level of significance was 5%, this will be lower. But weight is normal because it is higher, so we fail to reject the null hypothesis. Remember, the null hypothesis here is we are treating this data as under a normal distribution. So other things that we can see here, so we are talking about height. We can see we have said height is not normal. So look at the QQ plot. The QQ plot, we expect that these dotted lines that are here, they should fall within this line. So if they are not, if most of them are not falling within the line, so that's one thing that will tell you that the data is not normal. The other question, the other thing is the trended normal QQ plot. You can see that the deviation from the normality. So if you can see, we have a point here which is 0.4. So we have most of the points are like we have another point here which is lower as compared to the normality. So we can see that it is really helping us to show how this data is not normal. That is in terms of height. So if you go again to weight, we saw this histogram. So here again we come here. It has told us that the data here is normal. And then again we can see this one. And here, so mainly to make a conclusive if your data is not normal or normal, This test, the test of normality, the Shapiro-Wilk and Kolmogorov test. But you can see that in this case, the Kolmogorov is telling us the data is normal. But remember, we cannot use this because our data doesn't have that high sample size. But if we could have a larger sample size, then we could have used Kolmogorov and say that both our data sets are normally distributed. So thank you so much, and that's how